Okay, here we go again. And we're back. So, I got something prepared for you here. We're going to talk about ranges. We're going to talk about the other kind. It's sort of like a loop. We talked about it before, switch case. It's a little bit like the if else. Now with ranges, the switch case doesn't. I'm going to use this GPT because it's highly visible. Let's make it a little bigger. That'll do. All right. So, well, that might be a little too big. Okay. So, can we get rid of this? Nice. All right. So ranges, all we got is the IO stream. We haven't advanced much from the first video, right? Well, I mean, we've learned a lot, but we're not using a whole lot more. We're just showing each thing individually and try to tie it in as much as we can. So we just got this function here. It just takes a number, and we know how this works now, right? So process number right here is actually taking number, which is an identifier. It's an integer identifier. Okay. And it's not reference. Ooh. Okay. Really not sure how that works. But, or if it works, we're going to find out in a moment here. Anyway, just to get an idea of this, let's see how small I can make it before it gets unreadable. That's probably it right there. So, so ranges is basically just a function we have here, and it has an if-else and else statement. And it's just trying to find numbers that are between these ranges, okay? So down here in our entry point, our int main, we're going to create a range of numbers, and we're going to use this special command here. We're just going to use auto. It's probably an integer. It's using std ranges. It calls into views and uses iota. And I thought, what does that mean, iota? I looked it up. Nobody really seems to know, but I thought of what it probably means. And I'm pretty certain it stands for iterate over them all. Iterate over them all. And Jason Turner said that he'd never really found a use for it. This was 7 years ago he made that video. It was one of his, it was like number 58. Remember I told you he's got like 358? So, that was 7 years ago. Oh, we're also going to talk about constant expressions, but we'll save that. So, iterate over them all. What does it do? So what it actually does is iterate over the range that you set here from 5 to 25. And it's just like, it's basically like what a for loop would do. It's, let's switch over to the code here. Okay, so it's basically, yeah, see, this is setting numbers, so we'd have to do it, we'd have to change this other for loop, and I don't want to do all of that. So, essentially, we would have another for loop, usually I is used in for loop to stand for. Remember I said descriptive? That's always set to 0, usually. And then it's usually greater or less than. Here we would be talking 25. I mean, if you know the number, you can put the number in. I'm just saying. That works in a lot of cases. But anyway. I don't need that one. correct. Okay. Okay, so if you were going to do it like this, you could just use 25, but if you wanted to just get like the max, you could just like set another integer, or, you know, they don't have to be single letters either. They can be whole words. Like I could say, but then that's not very readable, and you will hit some limitations at times. Hello. Hello, Liz. So, the way we're going to handle it is the simplest way. We're just going to set it to 25 because we know what it is. We're not going to mess with that. We're just going to try to make our own little range here. We're going to have to make like our range. Okay? And we're going to set that to 0. Let's see here. Do we actually need to make this an array? Hang on, I got one handy. This one here as a constant expression. We'll skip ahead. We won't even teach about constant expression just yet, but we're going to use it. That's the great part about code. You don't necessarily have to know exactly what that means just yet. If you have a pretty good idea, or the code just works, use it for now. So, what's going on here? Oh, this has probably got to be... these are... what constant expression does is evaluate certain things at compile time. It's an optimization keyword. These things in blue, all these things in blue, they're keywords. Let's see what's going on here. Why didn't that work? Oh, we need array. Okay. Yes. We'll just take this whole thing. And we'll get rid of it here. We'll get rid of all this. Let me make it smaller so I can see what I'm doing here. And we'll just save this for a rainy day. So, the way this was probably normally done, something very similar to this. Arrays were more prevalent in the past, but they do come with some benefits. Constant now can support loops, everything except the try-catch block inside can be optimized. For something simple like this, like a constant array, that's the kind of thing it optimizes for the compiler. And it being that these are constant, it's just announcing that it's before everything else and it's constant. So it's a constant expression. The whole expression, it's like a function that is constant. It's kind of the way. We could do constant, that's different. And we'll learn. We'll get there. But for now, we're talking about arrays, and we're talking about, a range just like this, like 1 through something, or 5 through 24, etc. And then we want to be able to do something with it, so we're going to seek out those ranges, like it did in this example. It's processing ranges and going through this if-else statement to sort out which ones. But the other more consistent way people have done it, other than that cool iota command that no one ever uses, that's what that does. It iterates over them all, and it creates 6, 7, 8, 9, all the way to 24 between these two. Whereas you would have to write them all yourself in the array. or you would have to run the array through a for loop or something like some kind of loop, and or set them all individually, which is even more work, and then you wouldn't have this cool constant expression. So for a small range, this might be the best way to do it, the fastest way, much faster. But this is definitely by far the most user-friendly, easiest way. Then you get certain optimizations. You got the auto optimization, which could optimize or unoptimize. You've got another for loop, so you'd have two for loops in that case. Essentially, if you did it this way, you'd end up with something more similar to, you'd have to add this code in. So you'd have more code and another for loop if it was a large range. So this keeps all that out. It's not written. Each line in here is a compiler optimization. If I do that, it takes longer to compile it. Not by much, about as much as you'd think it would. But it's an optimization, and if you have 1,000,000 lines of code and you do that to 2,000 of them, now you've got 0.0002% optimization. So considering that, not overly considering it, because optimization is something you should do every so many stages. Probably optimize just before release if you have the time. Always, I don't know. Maybe not always, maybe every other time, maybe every 10th time. Maybe you do a whole optimization pass. It all depends on how you want to lay that out. But for now, let's just learn how to code, right? So you've got the constant expression auto here, so it's similar, you know. But to use, none of these are actually the most modern way to do it, but a lot of times you're going to end up writing your own code, and on the fly it may not be prudent or even possible at the time to think of, the iota command and put that in. So you just write a quick for loop and it assigns your array, and it's not a constant expression because that wouldn't be optimized anyway, and you find some other way to optimize it, essentially, is the real world case. But in this potentially real world case where you would have 5 of something in an array, maybe that's your thread. You could write this as a thread pool array, perhaps. And the optimization of it, because you're always going to have a finite number of threads, like we talked about in the last video, the last stream. The comments are blowing up. Hold up. What am I doing? Programming, yes. Would you ever waste your time with coding? Name me one website that's actually still worth using. Software has failed humanity. I love you. You definitely got to stay and comment more. You're good to bounce things off of. Why would I ever code? Games, dude. Humanity can burn. I'm going to play games. I want to be playing when the meteor hits, you know what I mean? So web apps and apps just keep getting worse. Why can't ChatGPT just do all for you too? I code with ChatGPT. And it's all my copyright. And I release it free to the world. Muhaha. Why do you have even look at the code? Because ChatGPT, the next one practically makes it so you don't have to look at it. But I think we're probably a good 5 years away from that kind of technology. That's kind of what we're building, dude. That's kind of what we're building. Wait and see. Write plugins. Learn how to code from this. Write plugins, okay? And we can build a single program that can do anything, that can be interchangeable. You can just turn it on and off like a plug-in. Like you want a calculator, just plug it in. You don't want it no more, it's taking up too much space, unplug it. And have the AI learn how to use that. I look like I'm AI generated? Well, thank you. I didn't know I was that beautiful. You have that G-Man from Half-Life aura? Yeah. I'm autistic, so I gotta take my meds, you know what I'm saying? You have that G-Man. Okay, I read that. Good stuff, man. Good luck. Well, thank you, Elijah. Thank you, Elijah Green. You're the polite one in the group. But I'm glad you're all here. Stick around, learn how to code. You'll see how powerful this is and why you should be doing it. AI, let's code some AI. That's where I'm at. If you guys want to like get together and put all our money together, we can go and get a single server and we can run our own damn AI. What do you think about that? You can all be shareholders. Hold up. Wait a minute. Put a little C++ in it. All right. We got IOStream array. And what does this do? We don't know. Let's find out. Oh, we failed. We failed as coders because you know why? It works. But if this was like OOP and it was a more complex implementation, that would have failed because I didn't clean. Now it's clean. Now it's not gonna try to overwrite a running program like this. Oh, it's up to date. Oh wow, it's running multiples. That's because when you hit this, it shuts it down. But anyway, 1, 2, 3, 4, 5. I can't make the console any bigger. Oh, I can. Look at that. Wow, the wonders of modern technology. Am I right? It's amazing. 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 So cool. All right. Didn't even know you could do that. Okay. Now that we understand how it kind of used to be done, or another way it could be done, with constant expression and a lot of optimization, let's look at the user-friendly kind of... The whole point of this was I was trying to put a switch statement here. But you can't. You cannot do that with ranges. The ranges would not work with this as a switch statement. So, it became a ranges tutorial. And you can clearly see how this works. This is iterate over them all, and if that's not what it's called, it is now. And it's a pretty cool function I didn't know about, but I'll definitely try to use that. When I went to Jason Turner's, somebody had written the comment that he thought that they used it in C++ tournaments. So this might actually be the standard template library. I haven't been able to write anything that's faster than it. And in C++ 23, you can compile it directly in statically as a module, which is like blazingly fast. It instantly compiles. I'm talking about the entire standard template library compiled into your program, into your executable, instantly. So it makes it even faster to use it because it's statically compiled into your code. It's got its own implementation now. So that is the number one reason I'm using C++, because I can't stress this enough. C++ 23. So, when that day comes, when it's perfectly stable and totally integrated into VS 2022, let me show you where it's at. Oh, not that. I think just one of the projects. Right here. right here where you choose your language. You can only go up to C++ 20 in VS 2022, but you can preview the features, and there was a tutorial on how to enable this and use it. But in the latest patches, it works without doing that. So you can just enable this and you're using C++ 23. Problem is, it's a working draft, so some things are going to be missing still. You have to, but now use C++ 20. And a lot of people actually code in much older versions, because if you're going to write libraries, writing it in C or C++ like 11 is ideal if you know how. Because it's not only faster because it doesn't have the extra overhead, which is very slight. It really doesn't make much difference. If you're not calling into libraries, you're not. Anyway, so it makes it so that, again, YouTuber makes his own operating system, implements C++, that's all he's got. You have to code it in assembly. So give people a break, right? Not only that, it's more stable. It's a longer known, there's known instabilities and things, like just like we know that in C++ 11 we didn't even have what we can use in classes today. And they used to recommend using friend classes and all this, and it's complete garbage because it was never used as the way it was intended to be used, and it just broke everyone's code. Basically quit coding for 5 to 10 years. Or they made it in the industry and were, taught. But this had a massive effect on open source coding, and which has a massive effect on the industry. And people drifted away from C++, so much so that Google themselves disliked its failures, or their failures, and created the Go language. You can use Go. It's cross-platform. However, you've got to rely on whoever made that code to continue that code. And I don't think anybody's as stable as the guy that makes C++. There might be organizations that are making things, but those are more likely to disappear and stop updating than anything else. Open source is the only thing that's consistently reliable, and we all know how that is reliable. So you're practically left to code your own stuff. Why not code in the most fundamental language that makes it the easiest that you can tolerate? And for me, that's C++, and I know other languages. I don't know it fully, but I've scripted C# and Unity, and I've tried to learn Java, but I think the similarities or differences, or the combination of the two, causes it to be very difficult for a C++ coder to learn Java. I've learned more just watching things since trying, but Java is now, as far as I'm aware, a dead language. There's nobody coding in that anymore. It's too insecure. There used to be a way to obfuscate it, and you can pay for expensive tools to obfuscate it. With modern computing, that can be broken much easier now. So I think that's the problem with Java. Public static void main args mad easy. If you Google John Purcell. talking about? Public static void main args. Dialogue editing series. Dialogue editing. "14 years ago, bro." Hold on, what is this though? It might still be valid, but 14 years ago it would have been C++ 11. We're now on C++ 20. So it's not likely to be too relevant. Oh, I guess I was talking about older languages. Dialogue editing for motion pictures. Huh. Dialogue editing.
For the music.
Pictures. Is this you? Then you can learn Java of programming videos. Oh, yeah. Well, I mean, I know. YouTube. Go YouTube. You could have just said that. But anyway, the point is, I wouldn't want to learn Java. Yuck. I'm a C++ dev, man. But I definitely don't want to learn no Java. If I was going to learn a new language, it would be Go, because it's cross-platform. Or with some Rust. But you know what's happening with the Rust and the Go people? They're quitting that shit and coming back to C++. Why do you think I'm here? You should, if you know about that video, you should know that. Or you just voting. Probably is the case. Which is fine. That's what a lot of people do. But it's not what I'm doing. What I'm doing is turning that around. To either bring people back who attempted this once in their life and want to continue with it and need someone, I don't know. If you watch some of the tutorials, I have a very different format. Let's just say that. I'll tell you what, it's bugging me. It's already all the way up. Anyway. Let's get back on track. Okay, that's ranges. We're done with that. You've seen the code, you can play with it yourself. Now, let's get rid of that. We'll keep IOString. Okay. Let's take a look here. Okay, this is the switch case. And you see this one has a constant expression for the switch case, which was why it was a little bit vital to explain that. So this one has what's called an enumeration class. Now back in the day, it used to be this, okay, and you can still use this, but this is, what did they call it? Type descriptive. It just announces to the compiler that is an enumeration and makes it type safe. That's it. That's all that class does. So you now do, what is it, class structure or struct class? This is the other type of, I believe they're called data variables or data type data containers, something like that. Anyway, there's a struct. We'll learn about that with the entry point. Enumerations are just basically a list of numbers. Each one of these, you can see, represents a number. So when you call color, it's just a number. If you call color red, it's going to return the name red, but it's also just a 1. And cases work on a 1, 2, 3 basis. So you'll notice that red, green, blue are all in the same order because they're actually equal to 1. 1. Oh, it doesn't like the 1. it wants like a oh, I see, it's before it wants like a constant expression, but it basically wants a predefined I'm not even sure how to describe that, but anyway, case is one of these things. It's kind of a keyword. The switch case is a keyword. This goes all the way back to C, I believe. So does enumeration and possibly struct, but struct was probably a little later on. Struct was actually enumeration. Enumeration might be the one that was added later on. But anyway, this is actually returning constant character 4. Okay, it's actually returning the string, but it's returning a constant character. So a constant character string. It's an array of characters, something like that. Well, that's odd. Why is it in 2 places? Get color. So it's actually, okay, this was a result. Okay, so what it's showing here is the old constant expression way from like C++ 14 through 17. But there's also the modern C++ 20 way, which is to use the enumeration class, which is actually much better than this whole switch case constant expression. This will probably print out twice. Let's see what it does. Oh, we got that freezing thing going on again. CPU maxed out? What's going on here? I closed it early, so I caused that error. There we go. Color is green, color name green. Now why did it do that? Well, remember I talked about the cleaning and how, well, it was running, but the cleaning and the, this is the kind of thing right here. Things like constant expressions, things that are pre-compiled, pre-evaluated. That's what's going to get all mangled when you don't clean it. And you're going to wonder why red equals green and green equals red. And at that point, a lot of people end up giving up their code, right? They're like, oh, I can't do this. So I've gotten so far and I can't find this bug. That's why you got to go slow. And you got to, what you do is you see how each time I'm showing you like a little tutorial it's separate from everything else, and I'm not trying to jam it all into one thing. That's how you code. You gotta make it work and then implement it slowly. Because if you don't, you're gonna end up with bugs you can't solve, and then you'll quit coding. Or you'll just fail and never make the game. And that's the whole point of what we're doing here, so I guess if you're doing something else, you can do that other places. No, we're doing a what? Message retracted, would you say? What did you say? Once you learn the hardest, go will be easy, young grasshopper. Bro, we're making a... What are you talking about? We're making a game engine. It doesn't get any harder than this. I've already done it. I'm the one that taught GPT how to do it. You're welcome. Anyway, so speaking of modern ways, something wrong there. Oh wait, oh yeah, do the other one. So we do need that. Oh, what happened here? Oh, this one, okay, you do need both. So this one's determining the name, and then this one's it's just an example of choosing one. And it chooses green. So that's the switch case. You can see how that's better than if else state finite way. If you just want to return, or if you just want, you can run code here. You could do that, but you're going to need to put it in its own scoping brackets. Otherwise, it'll only run the first line. That's what happens when you don't have these brackets. It'll run the first line, and then the second one will fire, but it'll fire even in the case of it's not supposed to. And this doesn't exist. That's why it's red. So that's how a switch case works. So we've covered that. And this is not that widely used, but these, if you can turn stuff into these, back in the day, having everything as an enumeration meant that almost your entire program compiled at compile time. So it was just an instant. It was the closest thing you got to having a quantum computer back then. That's what I'm saying. It still is. So get as many of these as you can and get rid of all the other code. That's how you want to program, for real. And if you're going to make things like this, probably wrap it in a constant expression and get it to act similar to this. So that's functional programming. And now, if you use if statements, if you can make a game like this. It gets a little more complicated, but here's the thing. I've developed a software suite, I guess you would call it, called Almond Core. And Almond Core is the core of a game engine minus all the rendering and heavy stuff that you wouldn't want in any application, because it's not just for games. It's more of a, I guess I call it a software engine. It's got an entity component system in it. It's a little heavy for certain things. But if you're talking mathematics calculations, you need 2D physics and entities and agents, and every program needs multi-threading. If it's anything larger than a calculator. And a calculator can benefit from multi-threading as well. Especially the way computers work, where they pop and glitch. You saw my console do it just because I'm streaming. When you multi-thread it, it's not going to reduce that, but what it's going to do is it's going to allow everything that it's supposed to do to happen while it's frozen. And then as soon as it pops into everything it was already supposed to do. That's why multi-threading is awesome. So you now have the basic set of stuff I began with when I began with C++. Almost everything I've done since, except for my work with Ehrlich, except for doing bug hunting on tons of stuff and trying to get things that shouldn't compile to compile, and learning cross-platform stuff, I've just used GPT more or less. I've now got a game engine. The one tool that I had it right. Now, the prompting was a pain in the butt. I spent 6 months every day dealing with the prompting to get this thing to comply, because it has a learning curve and somebody has to teach it. Nobody else was teaching it. But it was learning things along the way. Somebody else was teaching it certain things. It was starting to correct its errors. And I put a lot of feedback towards the developers that caused them to completely rewrite it. And they wrote into the thing. It gave it every so often, it'll give you a double prompt and ask you which one you want. And that goes into ChatGPT O, and now it's going into ChatGPT OA1 or whatever. That's their alpha for their new one. And the new one is so damn good that it can be used like out of the box to do all the stuff. And every single one of these tutorials that I've been giving you, I just simply have ChatGPT write it up for me because it saves me 10 hours of work. And I don't know that I would get it right. I would stumble through this. I wouldn't have written it as a constant expression. I wouldn't have written it as a constant character. I would have done it probably as a string. But now looking at this code, I've learned. And you've learned along with me. And I know enough about bug hunting to keep a project alive. I know enough about optimization to keep my code alive long enough to learn about it and to perfect it. I've already used GPT to write an engine that does more than the other free engine, which is not totally free, which is called Wicked Engine, which I was working with before this. And on Wicked Engine, he uses a lock-free queue with a spin lock, which is not a bad design. I've come to learn from extensive work with red queues and GPT. Because who am I going to rubber duck off of? Nobody I know in real life even has a computer program. So I use GPT as like a coworker, and it does all the bulk work. It's like the junior programmer, or the only you don't need a human for that anymore. Yes, GPT has replaced interns. As soon as you can program, see, this is a project you work on. You got to make GPT into my coffee maker. Then it can make coffee. Okay? And have a conversation with me if I want about mushrooms or something. I don't know. It should have like extensive knowledge of South America and other places that sell coffee. Yeah, makes sense to me. More robots. More robots. I'm here to help you learn how to write code for more robots. And if anybody wants to hire me, I'm for hire. But I've been doing programming for 15 years. I kind of gave up 10 years ago, and I had children, and I had several children, and these several children have needed raised, and I have disabled children, so they need extra attention, and I've been doing it more or less alone. And because of that, I have not been able to code for the past 10 years. So now that my kids are growing up, and I've moved my computer into the bedroom where I can complete these live streams without too much interruption. Yeah, that's where we're at. And I have always had a desire since I was 6 years old and began to become a gamer. I became a hardcore gamer pretty quickly, and it's only grown worse over the years. And ever since I was probably 13, I've been reading magazines and things about computers till I eventually had a computer when I was, an adult. And I've been programming. I actually started as an animator and modeler. I'm more of a 3D artist, and I couldn't find groups weren't working for me. So I'm solo, and I had to learn how to program. So I taught myself. And now I have way too many jobs, and I've taken on more to give you free stuff. So be nice to me. I'm that guy. I'm him. So I already know that just from the extensive, like I said, I got the project, I kept it alive, I did the research to learn, is my queue good? What are the queues out there, etc., etc. I've gone through the multi-threading, I've gone through the entity component system, how to get this entry point library. And let me tell you something, it is not easy to get ChatGPT to stop putting main into C++ examples. It wants to do it even when you tell it not to. Repeatedly. For months. So I could have probably done that a little easier. I'll admit that one. But you live and you learn. And you learn by doing, and by doing these tutorials, it helps me to learn more. And I'm going to need that knowledge being the proprietor of a free game engine. So I think I've nailed that home. We can probably not have this discussion. Which one is this? This is episode 10. So if you want to know where I rant about why I got to do C++, what I'm doing with my life, who I really am, where this project started, where it's going, it's all in number 10. Remember that. So, let's get back to, we know how switch statements work, right? Switch, and then we're going to take our identifier for our enumeration class to enumerate to the number 1, which is ridiculous, but with this function gives us the ability to call it by name. So I could actually do not sure if this would work, but we could try. Yeah, I didn't think so, but there's a way we can use that. I'm not precisely sure. We could say that, no, we can't, because it's an enumeration. It's just set up. I mean, you could do it the other way, but here, if you were to say, is that what it's even called? Red? Okay, yeah. Why doesn't that work? Oh, okay, yeah, it's still of parameter type color, so this only evaluates using this enumeration, so yeah, anyway. It is good to do it like this rather than to have a floating number somewhere, because it contains all the, and that kind of describes what a container is. Enumerations, structures, and classes are containers, and it's containing a list of numbers. It's not a range, although you could, well, you wouldn't need to set it with a range, it just automatically. And then there's something interesting about enumeration where the last one is always a total count. So it's either unknown, or you could call this count. That's more descriptive. Or something like color max, because it's going to be the maximum of all colors. Something like that. That's probably a bad one, but total count is fine. Yeah, switch case, it all depends on what the condition is in the switch that will require what's in the case. And because color is an enumeration class color, it's going to expect one of its enumerations as the case argument. And then break, after you fire your or whatever, you break out of it, and then it ends up down here. Can you see that okay? Yeah. So your class, well, your enumeration class. But you could just as well put a class here. You could put a range there probably. Well, we already learned that ranges and cases don't work together. So if you're going to use ranges, you probably have all of this switch case mess. I don't think that switch case is a popular one in modern C++. But if you were going to do it, this is how to do it in C++ 20. The enumeration class for type safety, which right there tells you this is probably an older way to code. What else was I going to show you? I was going to show you constant expression. We did talk about that. So there's a difference between constant expression in older versions. Like I said, loops and branches are now possible in C++ 20 and inside of constant expressions. You can't use try-catch blocks. But if you were using C++ 11, it just introduced variables and simple functions, and then in 14 relaxed rules where you could have multiple statements. And then full control with loops, branching, and more complex logic in C++ 20. And then, of course, it was done with like factorial and stuff like that back then. Or this, I guess this is the modern way here. Conditional logic with factorial. Okay. So that's something else. And that's it. That's all I had for that. Ah, man, there was a bunch of stuff I wanted to cover about the last stream, but nothing's really popping out at me. Here's my GitHub, since the audio cut off on me last time. Now, Almond Engine is just empty right now. It's not finished. We're going to do that live on these streams, actually. And Almond Core is not... it's here. You can play with the code right now, but... yeah, I better remove that, actually. So that doesn't end up confusing anyone. But anyway, it's here and you can use it. But it's far from complete. I've learned a little bit since I released that a few days back. And let's see here. We already learned concepts, but this is modern concepts with integral types and stuff like that. Because back then you would do like integer, and if you passed it an integer that wasn't an actual integer, then the concept would fail or error or something like that. So now they have is integral v, so it can actually look at the template type and see if it equates to the same type well, probably this just gives you better error handling. Let's see. Yeah. Help avoiding cryptic error messages. Right. Because it is integral. So instead of integer, it's a concept template. So this was like the old template. And then the concept template just asks, is it integral? And then it inherits into it or whatever. It's not inheriting, but anyway, it's instantiated into it, or rather not an instantiation because it doesn't create it per se. It's a template, but it's forward declared inside of it. There we go. In its instantiation or in its implementation or declaration, this would probably be its declaration, or this might be part of it as well, but this would be the, what did I just say? I forget now. Anyway, that's concepts, modern concepts, with better error handling. There's ranges. Oh, coroutines, yes. Let's talk a little bit about that. And we can take a look at modules too. Remember I said in C++ 23 they had modules? You can actually use them in C++ 20, but it's not complete yet. Don't use that yet. Unless you know what you're doing, I guess. Then there's also compare. Compare looks like it compares pointers like directly. That looks handy. Coroutine works like this. You have a promise type, and then it can suspend. But there's also an implementation I have somewhere that I'll show you. I'll show it in next stream. Where it has like pause and resume for coroutines, so that when they need to communicate, you just pause them and communicate, or you just pause them all and let them all communicate, and then resume them all. Wow, 95 views already. Those stats are weird though compared to what actually shows up when the stream ends. But yeah, you'd use co-await, co-return, co-yield. Did they show that? Did it show that? These are the old ones from the other day that I was trying to show. Hello from a thread. Here's threading. So now you can use JThread. So you don't need to manually join the thread. This is modern. This was introduced in C++ 23, I'm pretty sure. And so instead of having that join, where is it? It doesn't, there's not a threading example here, so I don't think so, yeah. But anyway, in the old way, you had to have thread join here. I can actually show you. It's in, I've used it in here. This is something that needs to be fixed. I might have fixed it already. I'm not sure. It's been a few days. I took a break after I finally completed this thing because it literally took me a month and a half solid. And I never gave up on it. And here we are today. So that's what I suggest you do. Do what I did. Become successful and famous and all that. Or something. Or not. But yeah, you can see that my project here for Almond Core, it runs inside of a struct, dude. There is no int main. That's all in the library. It handles everything. This is showing a whole example of what it can do with the loggers so that you can extract, like in your own games, you can use Almond Core's logger. So that's something you use in all software. Got a timer. It doesn't have an example for that here. The example is internal in the engine for that, I think, at the moment. It's got an example of scene and entity management. It's got an example of using logging with that. It's got an example here of creating some entities and moving them. And it just uses a movement event. So what it does is just moves them over time. Like the code is in the engine. Like, where is it at? Right here. This is the movement event. Notice there is no implementation. Interesting, isn't it? There's no code that actually moves anything. Well, technically it prints it. And the movement might actually happen in the move, but that's std move. That's a different kind of move. In update, it adds the movement event as a, I think it's just using it directly. It's just directly calling to movement event. And then it's adding a movement event to the event manager, which might actually be goofy code. Oh no, it's a special function for movement event. But this is something that would be called translation, and it would be turned into the translation component of the entity component system. And because the way that the engine is built, you can do stuff like use it outside of the engine. So just because movement event will have a movement event component within the engine that you can attach to entities, it'll also have the ability to use it abstractly outside of the engine for your own movement events. It'll still only move entities, but you can get it to move in custom ways, I think that's what I'm getting at. It really doesn't matter what I'm saying about it now, because like I said, this still requires a lot of work. We're going to go through it together on the stream, and it's going to change, or I'm going to change it to work the way that I'm saying, or a better way. So, but I believe the way this works is if you don't run the engine, it will basically run without you, and it'll do its basic standard startup and show you a bunch of information or something. Kind of the way it pretty much functions the same way that Wicked Engine functions. This engine is modeled after Wicked Engine. It's not stolen from it. I didn't use Wicked Engine source in GPT almost at all. I did a little bit for certain parts to understand, but I never directly coded from that. I never started from his code. Just so you know that. So any resemblance to any other engine is purely coincidental. This is handwritten by me and GPT, and GPT was not capable of writing it until I taught it how, so it writes it in my namespaces. And it knows when it's gotten so familiar with me as an individual that it actually knows when I'm writing things for Almond Core intuitively, because it understands the design fully. We went through every single part of this, and to get it to all combine together, because I did lack the C++ skills to make this all but I've learned how to do that since then. And I've only come back to, what I was getting at is I've only come back to programming in C++ or programming in general since this spring. I've only been coding for about 6 months. What is it? It's October now. I started in March, but I didn't get into hard coding until middle of May, or middle of April, end of May, or beginning of May, something like that. And I've only been it only took me a month and a half to get Almond Core fully functioning, but I had probably worked with all the parts of it up until that point. Oh. But you can see the job system doesn't use mutex. There's no mutex. There is no locks. This is a lock-free system. In the Wicked engine, he has a lock-free queue, but he uses a spin lock system. So that it's a different type of system, but it is a locking system. So essentially, there is a little bit of a hitch there. In he's got a little extra time in when it switches from one thread to the next, but generally speaking, you're not micro-threading anyway anymore. It's not that terrible. No matter how fast your C++ engine runs, you're going to get to a point where it's fast enough where the CPU itself, or the RAM, or the CPU to RAM, or the cache to RAM, or the hard drive to RAM, or hard drive to cache, etc. Those functions are going to bottleneck your code at some point, and getting it to run faster is simply focusing on where those bottlenecks are until you adjust it in a way to where you create another bottleneck, and then you'll finally find out the limitations of the system that you're on, and realize all that optimization was for naught anyway, to some degree. You can only optimize to a optimal point. There is a curve. There is a what do you call that? Somebody knows the name of that. Anybody here know the name of that? A planing curve. At some point, the curve planes off, just like with AI. Here you go. Here's that thread join. So what I need to do is rewrite the job system that uses JThread instead of thread. And I could probably just delete that. And probably don't need that. And then it just becomes a for loop. It's not even a for loop anymore. It's just thread and then assign it. Store threads. I'm not even sure what this is doing. This is that's a weird for loop there. I'll have to look into that. We'll talk about that next time also, if I remember, if it ends up on the GPT and I ask it, and yeah, anyway, we'll get to it eventually, because I go back through my videos and watch them and try to pick out things and figure out what is a good thing to go into next. And I had a good plan here. I mean, yes, going and showing the rest of the enumeration class stuff, that's all very important to the fundamental layer that we're on right now with C++. We're trying to learn, from the ground up. So those things are the ground. That's all the groundwork. You've seen all the groundwork. There's not a whole lot more groundwork. Patterns is some of the groundwork. You should start to learn about patterns. But that's kind of a complex subject we're going to have to save for another stream. I think we've even gone, what have we gone, another hour? Where's the time on it? If we're up to an hour, we'll end it here. Because I don't want to go, not in this stream. We don't need to go any further than an hour. Yep, we're at like an hour now, so time to wrap it up again. And hopefully people are learning. If you're watching this and you're trying to learn C++ and you're practically just doing it just with me, and maybe you've gone out and looked a little bit, but you're not watching any other tutorials and you're just going through my series, please comment on those videos and tell me what I can include, what you're having trouble with, if you're following along so far, if you've gotten to the point where you feel confident that you understand what I'm doing here with these smaller examples. Not this job system, that's not what I'm referring to. I'm talking about things like this. If you're at a programming level where you feel confident about stuff like this, small examples, and you've been following along with me, feel confident, you're like, okay, I got this. Let me know. Let me know what you're struggling with, what, if anything, you want me to go over in the next or future streams. Get those comments flying, because I need some kind of feedback in order to really make this series hit. I mean, you've seen what I've done so far. You see this is all about education and free open source, and I'm not even asking anybody to contribute to Almond Engine. That's solely my own personal vendetta against programming and wanting my own game engine because I've been doing this my entire life. It is what I do. So, I would love some feedback, guys. I'm not even trying to just, I'm not doing that. I just would love some feedback to know what we can do next, what you'd like to see next. And if you're just somebody else you already know a little bit of programming, that's fine too. Let me know some feedback. What you would like to see, anything you'd like to learn about, something you struggle with. If you're like me, when I first started, I was like, what in the world is this? I could not understand what a container is. And I really couldn't understand what constructors were. Because what the hell is that stuff? Like, I don't, this makes sense, right? But why have it in the player? And then I started to understand, okay, so you might have several of these things. Like you might have an item. An item has totally different qualities than player, right? So you might have totally different qualities. So then it makes sense to have different containers for sets of qualities or variables to the object. And what is an object and a container? Those are two totally different concepts. But classes are both. They're both objects and containers. And to me, I consider those initializer labels, those, what did we call them? Descriptors. I consider those to be like objects. I call them objects. I don't know if I consider them like classes in code, but in my head I call them objects. They act very similar to objects. And in the code, you'll start to realize that these terms are very ambiguous even to the compiler. And that very few things are finite in code. And you can bend this to your will and come up with concepts that nobody's ever come up with before. Well, I'll give you an example. One guy was building an engine 13 years ago, and what he did was he just made something called a connector. And I'm like, so what does the connector connect? And he goes, everything. So what he would do is it was just some kind of a class that had functions that would attach other classes. It was, did I show you that example? There was a functional, it was like functional B. I don't know where it's at now. But anyway, he basically built a connector class that was just, in the constructor, it would attach to the class, and then it would, I don't know, people come up with the craziest things. But every mind is different, every human mind, and that's why LLMs, they plane off at a certain point, because you gotta get that unique knowledge from unique human beings. And if you were to make a game, there would be something unique about that game that only you could put in, or only you would have. Or it's not like everybody's making video games. I mean, maybe after they watch this, but there's a finite amount of people making video games. And some video games just have so much work involved, tedious work, that you could have GPT do. Like Rockstar Games has, 500, supposedly they have 500 programmers or whatever, but I don't believe any of that, because quite frankly, you can't treat people to work well together. You might get a team of 5 programmers, like core old school programmers, to write the engine, and then have your programmers tackle and individually try to write their own code. 10 of them would fail, and one of them gets it right, and you use that code and pay them all. I don't know how it works, That's why interns are a big thing at game companies. Just saying. Anyway, my name is Adam Rushford, and C++ is an amazing thing that can change your life. Life is just better after C++, and my name's Adam Rushford. It's been fun. It's been real. Happy coding.